In the last section, we started putting together our separate worker thread. At this point, our separate worker is doing some very simplistic work. Whenever our application calls post message, which occurs right here, our thread executes the function that gets assigned to onMessage. So that's this function right here. Our worker then declares a counter variable and counts from 0 all the way up to 10 times 10 to the ninth, whatever it was. It counts up to a very high number. And then it eventually communicates the result back over to our side of the application. So when our thread calls post message, the onMessage property back inside of our application gets invoked. So that should be my counter right here. And at present, we're just console logging out that value. So let's try running our server now, and we're going to test this out inside the browser and just see what happens. One thing I want to mention very quickly, notice that at present, we're just console logging this value, and we're not actually responding to the incoming request or anything like that. So we will see this hang inside the browser. All we're looking for right now is a logging statement out at the terminal. So I'm going to flip back over to my terminal. I'll start my server up with node index.js. And then I'll go back over to my browser. I'll open up a new browser tab. And I'm going to go to localhost 3000. Okay, so again, this page is not going to resolve to anything. If I go back over to my terminal, however, you'll see the console log appear right here. So it's data times 10 to like the ninth. That doesn't look like 9, but maybe I'm off with like times 10 to the ninth. Whatever. You get the idea. There's a whole bunch of zeros here. I apologize for being off on that. I know I'm totally wrong, and someone's going to let me really know scientific notation here in the comments. I know it's going to happen, but it's okay. I welcome it. Anyways, so we can now see that clearly our worker thread is doing some big calculation here and then returning the result back over to our application. But we were just a little bit off here with the argument naming. So the object that came back right here was not the actual counter itself. It was some data object. So let's call that thing like, I don't know, message. And then we'll just console log out message.data instead. And then how about to respond to our actual request, whenever we get some message back over from that thread, we'll call res.send and we'll send back that number that just got calculated, like so. So let's now restart our server and try this out again. So I'm going to restart my server. I'll then refresh the page. And then this time I should fairly quickly see a result appear on the screen. Unless I got an error. Let's double check. Oh, my mistake. Res.send, we passed in a number right there. And whenever Express sees a number, it assumes that we're trying to send a status code, not the number that we think we're sending. So to turn this thing into a number, we can just join it with a string, like so. So now that's going to be cast as a string, and Express should think, oh, we're not sending back a status code, we're sending back some just plain number. So I'll restart my server, and we'll try this one more time. Okay, there we go. So now we see that result computed by our separate thread appear on the screen. All right, that's kind of all I really want to do around worker threads at this point, just to show you, hey, this is a thing, and this is how you communicate with them. If you read the documentation around web worker threads, the author here claims that there are some distinct performance benefits over using clusters, but honestly, I'm not in entire agreement with that. So my opinion really is make use of a cluster before you start reaching for these thread things. Now, last thing I want to run for you very quickly, just to show that we do get some level of concurrency out of this, is to do an actual benchmark as well. So with the benchmark, we can at least confirm that there is some real concurrency going on here, and we're not just like stacking up one request after another when we do this calculation. So if I do something like ab-c1 1 with localhost 3000, so this is going to do the count just exactly one time, we can time this, and then we can run it again with 2 requests running at the same time, and we should see more or less the exact same time. Remember, I'm on a dual core computer right now, so every operation that I do in like 2x2 concurrency is going to, in general, run like twice as quickly. Okay, so we'll run this one. It takes about 733 milliseconds. And so now if I do it with some level of concurrency here, so 2 at the same time, those worker threads should take advantage of the 2 cores that I have in my computer and run the same operation in roughly the same amount of time. Okay, and so I see about 791, which is close enough for me to feel like, yeah, that's pretty darn close. 796, wow, that's getting, okay, there we go. More or less, I'm pretty confident to say, yeah, it's basically going about the same speed. Okay, so that's pretty much it for worker threads. Let's continue in the next section, and we're going to start taking a look at our next big topic. So quick break, and I'll see you in just a minute.